Howdy-ho, neighborinos. I come to you with episode 10 of the Solar Power System Installation Reality Show. What we have here is our DC distribution panel. This is, I believe, a 8 by 12 NEMA 1 rated junction box. I don't know if you can see that. Cutout box, whatever. And basically, it was included with a bunch of miscellaneous electrical things that a friend of mine was kind enough to share with me. It was empty when I got it. So as you can see in the back here, we bought a, I think it was an 8-inch by 20-inch or similar sheet of 22 gauge steel from Lowe's, which was a little thinner than probably what I should have bought, but I didn't really have tools to buy anything thicker. And the reason thicker would have been better is because when I tried to tap it for our number 1032 screws, or excuse me, 1024 screws, it would not hold a screw very well because of the thickness of the metal was not adequate. So what we did was we purchased two 80 amp DC breakers from a company called CBI, and CBI, you can pay me later, check should be in the mail. This is a Curve U2 as it's known, and it is rated for 80 volts and it has a 10,000 amp interrupt capacity. Now it shows to be a 2-pole breaker, but in reality it's acting as a single pole breaker because both poles, if you can get a good look at that, are ganged together with a pin through the handles as well as a copper bus both on top and bottom to get a rating above 63 amps from CBI. That's the way they come. We bought two of these, and these represent our overcurrent protection between the battery chargers and the batteries. So the batteries will be fed individually by these two breakers. The 60 amp breakers over here are by a company called AirPack, I believe. And AirPack, you can send your check. These are 160 volt DC rated. Everything has to be DC listed. That goes on your DC system. And they were provided by the same company that provided our solar panels from Miami, Florida. And they are straight single pole breakers. No ganging or busing required on those. And CBI, just so you know, makes 60 amp single pole units as well without ganging or busing. You'll notice in the middle here we have a 150 amp DC breaker, and when you go up that high, that is the highest rated breaker I think that CBI makes in a DC class. It is 80 volts. Now I probably shouldn't say that, but in the class that we were purchasing, I should say 150 amps was the largest they made. It is 80 volt rated and has a 10,000 amp interrupt capacity. And now this particular one is ganged all three levers and also all three poles. And on that breaker, I believe we'll have a 1-aught wire for our positive DC bus. This will feed our inverter input. We'll have a DC input on our inverter fed through this breaker. This breaker will be between the inverter input and the positive DC battery string, where the two battery strings are combined together. They will come up to this breaker, feed this breaker, come out of this breaker, and go to our inverter input. These breakers will be fed through our combiner panel. There will be two buses in our combiner panel, each one with 3 breakers, and those 3 breakers will bus together and feed into one side of this breaker, come out the other side, and go to our battery charger DC input. The DC output of the battery charger will come to the 80 amp breakers each and go out of the 80 amp breakers to the batteries. The batteries will then feed back into the 150 amp breaker, go out of the 150 amp breaker, and go to the inverter input, which will then have an AC output because it takes DC in and gives us AC out. And the AC out of that device will go through our 60 amp circuit breaker here that I'm getting ready to show you. This is a square D circuit breaker. It is 10,000 amp interrupt capacity, 60 amp 2-pole, and this will feed our 240 volts out of our inverter to our fuse box in the house. I say fuse box because this house was built in 1950. It's possible we may change that out to a breaker panel, but that's a job for another day. This box is rated indoor-outdoor. I paid an extra $10 to get the outdoor rated box just in case at some point I decide to mount it outdoors. I wanted to have the option to do either because we all know how projects go. They can change as they progress. And let me think here for a second. I believe I can show you our combiner panel. You may have recalled seeing this if you watched some of our earlier episodes, and I'm going to try and show that to you here. What this panel does is, as you can see, hopefully, if I can get the stage straight, this has 6 20 amp breakers, and they bus together here on the output. What I'm going to do is I'm going to cut this metal bar so that I have 2 buses on the output of these breakers. I'm going to replace one 20 amp with a 30 amp, and that will provide overcurrent protection for 2 separate strings of solar panels. The rest of them will provide overcurrent protection for an individual string of solar panels, so that I'll be able to get all 7 strings into a single box. Then I'll have 2 somewhat off-balance buses here that will feed my battery chargers. We have here the negative DC bus and the ground bus. Now, if you remember from the previous episodes, our DC negative is grounded through the battery charger. So this ground bus, if it's used, will be strictly for grounding this panel, but it won't be bonded to our negative in here. So anyway, we're getting ready to mount our DC battery chargers in the office, and hopefully here pretty soon that's what you'll be seeing.